Okay, good morning students. We are continuing with our chapter number 1, exercise 1.2. So in the previous lecture we are talking about the question number 1. In question number 1 we are find the fraction into the decimal form. But today in question number 2 they are asking what? You know that the value of 1 by 7 is equal to 0.142857 and bar means what? That these digits are repeated. So we can write like that 1 by 7 value is what? 0.142857. Once again it will be repeated, so it will be continuous. So can you predict what the decimal expression of 2 by 7? So we need to find the value of, if the value of 1 by 7 is equal to 0.142857. So what is the value of 2 by 7? 3 by 7, 4 by 7, 5 by 7 and 6 by 7 are without actually doing the long division. So here we do not perform the long division method, but from the 1 by 7 we can find the value of 2 by 7. So for what? So here we can write like that 2 into 1 by 7, because in the numerator term we can clearly see that what? Here we can write like that 2 ones are 2. So we already know the value of 1 by 7. So we can write like that 2 into, what is the value of 1 by 7? We already know that will be 0.142857. It will be continuous. So we will perform the multiplication, so we can find its answer. It is multiply with 2. 7 2s are 14, 10. So the answer of that, it will be 0.285714. It will be once again continuous. Similarly we can also find out the value for 3 by 7. So once again we are multiplying with 3. So we can write like that 3 into 0.142857. So once again we can multiply 142857 multiply with 3. So what is its answer? 7 3s are 21, 17, 25, 6, 8, 12, 4. So answer it will be 0.428571. So it will be once again continuous. Similarly we can find for the value of 4 by 7, 5 by 7 and 6 by 7 by doing the same procedure. For 3 by 7, for 4 by 7, once again we can write like that 4 by 7. So 4 into 1 by 7. So then 4 multiply with 142857. So once again it will be continuous. So we can write like that 0.142857. It is multiply with 4. 7 4s are 28, 20 plus 2 22, 8 4s are 32 plus 2 34, 8 plus 3 11, 4 16 17, 5. So answer is 0.571428. Once again it will be continued. So similarly you can also find out the value for 5 by 7 and 6 by 7. So you can find it at your home. We can doing the same procedure. So here we cannot use the division, but from 1 by 7 value we can directly find the value of 2 by 7, 3 by 7, 4 by 7 like that. So it is very easy. Now question number 3. In question number 3 what happened? First of all, express the following in the P by Q form. P by Q means what? Rational number form, where P and Q are the integers and Q is not equal to 0. Denominator term will be not 0. Otherwise it will be not the rational form. So first question it will be 0.6. So for that we have one procedure. If the digit is continuous, here we have a bar. If digits are continuous, so it means it will be recurring or repeating. So we can write like that x. So first of all we can write like that, let x will be 0.6666 because here we have a bar. So it indicates what? These digits are repeated. Now here we have only one digit it's repeated. If one digit is repeated, so what we can do? Here we are multiplying both sides with 10. So we can write multiply both sides by 10. So 10 into x is equal to 10 into 0.666. So if 10 into x, so it will be 10x, and is 10 is multiplied with 0. So answer is 6.6666. So now here we have a 6.666 like that. So if we want to convert, we can also write like that 6 plus 0.666, because if we write 6.666, also we can write like that 6 plus 0.666, answer will be remain same. Clear? So now here we can see that 6 plus 0.666, but from, suppose it will be our equation number 1. So from equation number 1 we can clearly see that what? 0.666 is equal to x. So we can replace this with x. So 6 plus x. Here we can also write like that from equation number 1. Now if x is going to the second set, so it became minus. So 10 minus 1, so it will be 9x. So x is equal to 6 by 9, because this digit is going second set, so it will be in the denominator term. Now we can cut it. 3 2s are and 3 3s are. So answer will be 2 by 3. So finally we get p by q form. 2 by 3, it is in the p upon q form. So here here we can see that what? Here one digit is repeated, but in some case what happened? Two digits are repeated. So if two digits are repeated, so here we are multiplying with 100, and if here the three digits are repeated, so here we can multiply with 1000. So we have the same question as question number 2. So here we can also see that question. Question number 2. Here they are asking 0.47 bar. So for that we have the same procedure. First of all we can write like that, let x is equal to 0.47 bar. So here the bar is only, here we can see that what? 7 raised to bar. So it means what? The 7 is repeating digits. If they are writing like that, so here these both digits are repeated, because bar we have the both digits, and here we have only the bar have a 7 raised to bar, and here we have the 47 raised to bar. So that is the, if here we can we are showing that what? 47 raised to bar means what? Two digits are repeated, and here we have only one digits are repeated. So now here one digit is repeated, so it means what? We can multiply both sides with 10. So once again we can write multiply both sides by 10. So 10 into x is equal to 10 into 0.477. So answer is 10x is equal to here 4.777. Now we want to convert similar like that, 6 plus 0.666. But here we can see that what? If we want to convert the digit into that form, 0.477. So what we can do here? So for that, here 10x, and now we can see that we can subtract 4.777 minus 0.477. So 0.0003. So 4.3. So here we can write like that, 4.3 plus 0.477. Why we can write like that? Because here we need that value, because we want to we can replace that value with step, because of what? Here we need that value, because we can replace that value. So for that, how can we do that? First of all, we can write like that 4.777, and from them we can subtract that value. So here we can get that value, and that value here we can write. So 4.3 plus 0.477, so we will get that value 4.777. So now so here 4.3 plus x, and here we have a 10x. Now that x going second side, so 10x minus x, it will be 4.3. So 9x is equal to 4.3. Now 9x is equal to 43 upon 10, because here we have a 1 point. So for removing that point, here we can divide with 10. So x is equal to 43 into 10 into 9, because that 9 is going second side. So what is its value? X is equal to 43 upon 90. So that is a procedure step for we can find the value if it is in the decimal form. See, these both are in the decimal, and decimal we will convert into which form? Rational number form. Similarly for here, this will be the decimal form, and then we can convert that form into the which form? Rational number form. So for that you must remember one thing is what? If digits are repeated, then and then we can convert into the rational number. But if digit is like that 0.12345 then 124, so here digits are not repeated and it will be continuous. So we cannot convert that form into the rational number form. So you must remember one thing in your mind is that if digits are repeating or recurring, then and then we can convert that number into the decimal form. Otherwise we cannot convert that form into the decimal, or decimal we cannot convert into the rational number form. And the question number 3 is x is equal to 0.001. So it is the same example as question number 1 and question number 2. So you will do at your home, and if any doubts you can ask on my WhatsApp. And second thing, question number 4 is same as our question number 3 first. In that they have one asking 0.999. So it is the same as 0.9 raised to bar. So we will do the same procedure and we can find it answer. So question 3 third and question 4 you will be doing at your home, and if any doubts you can ask me on my WhatsApp number. Thank you. So in question number 5, what can the maximum number of digit in the repeating block of digits in the decimal expression of 1 by 17? It means what? How many numbers are repeated if we divide 1 with 70? So we need to find how many digits are repeated. So for that 17 divide with 1. So 17 divide with 1, so here we have 1, so we are starting from 0. So once again we will put 0, so here it will be 100. Now 17, we can write 17 5s, it will be 7 5s are 35, so it will be 85. So here we can write 85. So we have the remainder as a 15 because 10, and here we have a 9. Once again we can put it 0. So now we can check 17 8s and 17 9s. So 17 8s is 56, and 8 1s are 8 plus 5, so it will be 13, and here 9 7s are 63, so here 6 and it will be 15. So here we have 150, so we can start with 17 8s, so it will be 136. So once again we have in the 14, we will put once again 0. So now once again it will be start with 136. So here we can write 8, 136. So 10 minus 6, once again it will be 4. So 0, 0. Once again we will put 0. 17 2s are 34. Now 10, so 6, and it will be 0. So once again we will put 0. 60. So 17 3s are 51. So here we have a 9 as our remainder. Once again we have an 5. So 17 8s are 85. So we have an the 5 as our remainder. Next 50. So 2s are 34. So it will be 10 minus 4, 6, and here we have a 4, so it will be 16. Once again we will put 0. Now 9s are 153. So it will be 7. Once again we will put 0. Now 17 4s are 17 4s are, it will be 68. So it will be 2. Once again we will put 0. Now 17 1s are 17. So we have 3. Once again we will put 0. So 13. So once again 17 1s are 17. So 30 minus 17, it will be 130. Sorry, 13 as our remainder. It was 10, and here we have a 2. Once again we will put 0. So now 130. So it will be 17 7s are. Let's check. So it will be 7 1s are. So it will be 119. So now here we have an 11 as our remainder, because 10, and here we have a 2. Once again we will put 0. So 110. So it will be 17 6 are. So it will be 102 6 are. Now next, here 10, so it will be 8 is our remainder. Once again we will put 0. 17 4s are. So it will be 68. So 112. Next, here once again we will put 0. So 120. So here we can start with 6. So it will be 102. So 10 minus 2 8, and here we have 1. So once again 18 as our remainder. So it means what? We are continuing with the division. So after 16 digits, here see 3, 6, 9, 12, then 15, and last is 16. So 17 9s are. 17 9s are, it will be 153. 10 minus 2, it will be 8. So 18. And once again 17 1s are 17. So once again we can get 1. So here we can also starting with 1. So it means what? 16 digits are repeated now. See, once again we can perform the same division. So it means what? We can, here they are asking what can be the maximum number of digit. So here we can write like that, the 16, the maximum number of digit be in the repeating block digits in the decimal expression are 16, because if here we have a 1 upon 16, so it means 16 digits are repeated, and if here we have a 1 upon 15, so it means 40 digits are repeated. So here we can do the long division, and then we can find its answer. Now we are going to learn our question number 6. In question number 6, look the several example of rational number in P by Q form. We know that rational number is always in which form? P upon Q form. And we know that P and Q are the integers. Suppose we can take the one example, 3 by 5. So it is in a P upon Q form. So integers with no common factor other than 1. So see that 3 ones are 3 and 5 ones are 5. So both have the one common factor 1. And having a terminating decimal representation. So can you guess what property Q must satisfied? So they are asking what? So this property we must remember for that example. If the prime factorization of Q, so if the Q having the value of power of 2 or power of 5 or both, so then and then we can convert that rational number into the decimal form. Otherwise we cannot represent that rational number into the decimal form. So for that they compulsory follow that property. Which property? The prime factorization of Q has only the power of 2 or power of 5 or both. If this condition will be satisfied, then and then we can represent any of the rational number into the decimal form. Otherwise we cannot represent that decimal form into otherwise we cannot represent that rational number form into the decimal expression. So you must remember that one condition for that. Now question number 7, they are saying that what? Write the 3 numbers whose decimal expansion are non-terminating. So in the previous lecture we can talking about this term. What is non-terminating? Remainder will be not 0. It is called non-terminating number. And non-recurring. Non-recurring means what? Not repeating. So we need to write the 3 of example. So you can take any of the 3 example like that. First 0.1, 2, 3, 4, 5, 6, 7, 8, 9 like that. It will be continuous. Second 0.01, 001, 0001. So it will be once again it will be see that non-terminating. It will be not we cannot get remainder as 0. And second thing is what? Non-recurring. So digits are not repeated. Here 0 1, then 001. So it is not repeating. Same will be here 1 2, then 3 4, then 5 6. So digits are non-terminating as well as non-recurring. And third example 20, 200, 300, 400 like that. So it will be once again continuous. So in these 3 examples we can clearly see that what? Digits are non-terminating as well as non-recurring. So in question number 8 they are asking find the 3 different irrational number. So we want to find the irrational number. Irrational means which is not in a P upon Q form. Between the rational number 5 by 7 and 9 by 11. So we want to find the irrational number which is lie between these 2 rational number. So for that first of all we can start with our first number 5 divided with 7. So here we can start. So here we will put 0. 7 7 it will be 49. So here we have a 1. Once again we will put 0. 7 1s are 7. So here we have a 3. Once again we will put 0. So next 7 4s are it will be 28. So 2. 7 2s are it will be 14. So here we have a 6 as our remainder. Then 7 8s are 56. So 4 as our remainder. Then 7 5s are it will be 35. So it will 5 as our remainder. Then 7 7s are once again we have 50. So it means what? This 3 and 3 6 digits are repeated. So we can write 5 by 7 is equal to 0.71428. It will be continuous. Similarly, we can also find the division of 11 upon 9. So here we will first of all put 0. So 11 8s are 88. So 2. Once again 11 1s are 11. Once again 8. So once again we can get 90. So it means what? 81 81, these digits are repeated. So 9, we can write like that. 9 upon 11 is equal to 0.8181, like that. So we need to find the irrational number between these two numbers. So for that, the sequence is starting from 71 and here it will be 81. So we need to write the number which is lie between 0.71 and 0.81. So here we can write the 3 irrational number lie between 5/7 and 9/11 are, we can write like that, 0.721452, like that. So here see that it will be non-terminating as well as non-recurring. Digits are not repeating and the remainder is not 0. We can also write like that, 7 5 7 4 to 1 2 3 0 1, like that. Once again we can also write like that, 78 72 1 4 2. So we need to find 3 rational number which is lie between 5/7 and 9/11. So you can write any of the number which is lie between these two number, 0.71 and 0.81. The next last sum of that exercise is classify the following number as a rational or a irrational number. So for that, first example is under root 23. So we cannot find the root of 23. So it will be which kind of number? Irrational number. Second, under root 225. So square root of 225 is equal to, we can write 15. So we can also write like that, 15 upon 1. So it will be P upon Q form. So it is which kind of number? Rational number. Third, it will be 3796. So we can also write like that, 3796 upon 10,000. So once again it will be which form? P upon Q form. So that is which kind of number? Rational number. Next, here 3 digits are repeated. See, 478. Once again 478. So we can also write like that, 478 raised to bar. So if digits are repeating, so we can convert that number into the rational number. We can do the same example as in question number 2 and 3. It have the same sum, question number 2 and 3. We can convert that repeating number into the P upon Q form. So that is also which kind of number? Rational number, because these are the recurring digits. Last, 1.10100. See, sequence 1003040. So digits are not repeating. Every time the sequence will be changed. So it is not repeating or non-recurring. So these are which kind of number? Irrational number. So from them we can conclude the two things is what? If we find the square root, so we can convert that number into the rational form. And if we cannot find that square root of that number, so it is always irrational number. And second thing is what? If digits are recurring, then and then we can convert that number into the rational form. And if digits are not repeating, so it is always irrational number. And here we can see that what? Here the sequence will be ended. So we can convert that number into the P upon Q form. So it is always rational number.